विचार सार परमा आर्य जगत व्यापिनी वीणा पुस्तक धारिणी अभयदा जायन्धकारुपहां हस्ते स्मालिक मालिका विदधति पद्मासने संस्कृतां वन्दे तां परमेश्वरी भगवती बुद्धिप्रदं शारदां न शौर्यहार्यं न च राज्यहार्यं न मातृवाच्यं न च बाधिकारी द्वये कृते वर्धते नित्यं विद्याधनं सर्वधनं प्रदानं विद्याधनं सर्वधनं प्रदानम्.
Today is 6th of Pousha 2076. We can say today is the shortest day in northern hemisphere. So it is called winter solstice. What is it called?
Winter solstice.
Today is 22nd December and we have got shortest day and longest night. But in southern hemisphere, longest day and shortest night. So what is going on in Anupam Vidyasadan? Teaching practice, right? What is going on? Teaching practice. And students are going to present today in the chapter classification of elements. So without wasting time, let me call the presentators. Who are the presentators? Number one, Rabi Silva. Number second, Samit Mananda. Please stand up. Next. Who next?
Sujan.
Stand up. Sujan. You are also there?
Yes, sir.
Okay, so there was one candidate, Dipsika Singh, but her health could not support. So we will ask her to do in another chapter's presentation. Because how many students are in this class? 39. 39. So in each presentation we are asking 4 students. So in this group only 3 will be there. Now in other group there will be 4 candidates, right? So shall we hand over this stage to them?
Yes, sir.
Please.
Good afternoon to you all. My name is Samit from grade 10 and I am here to give a presentation on the topic classification of elements, which is a... So let's start. First of all, what is classification of elements? Classification of elements is the process of dividing the elements on different groups on the basis of their similarities and dissimilarities. The classification of elements make the study of chemistry more reliable and easy. For the classification of elements, we need there are some periodic tables. So first, let's discuss about the periodic table. Periodic table can be defined as the systematic arrangement of elements on the basis of the similarities of electron configurations in the groups and periods is periodic table. And in periodic, there are 2 types of periodic table, which are Mendeleev's periodic table and modern periodic table. So first, let's discuss about the Mendeleev's periodic table. Mendeleev's periodic table was made by Russian scientist Dmitry Mendeleev in 1869-80. This table can be defined as a table of chart which are made by arranging the elements on the basis of the increasing atomic weight or Mendeleev's periodic law. So Mendeleev's periodic law can also be stated as the physical and chemical properties of the elements are the periodic functions of the atomic weights. So there are many some of the Mendeleev's periodic tables has some characteristics which can be pointed as it is the first periodic table in which the elements are based on the atomic weights. There are 7 horizontal rows, the periods, and 8 vertical columns. The groups in Mendeleev's periodic table. Mendeleev left some gap in his periodic table so that there were more chances of having more elements discovered. There were many merits of Mendeleev's periodic table, such as it was the first scientific and systematic way of classifying the elements on the basis of the atomic weights. Many elements on that time were not discovered properly, so Mendeleev had left some gap for those elements. The atomic weights of some elements like beryllium, platinum, gold, uranium, etc. had some wrong positions in their periodic table. So Mendeleev arranged them in such a way that they are arranged properly. So there were many merits of them. There were also some demerits, such as there were wrong position of hydrogen. The hydrogen in his periodic table was not properly defined. So it is also considered as a demerit of his periodic table. In his periodic table, there was separation of chemically similar elements such as copper and mercury, gold and platinum are chemically similar, but they were separated into different groups of it. And there were also grouping of chemically similar elements, such as grouping of copper, silver, gold are arranged with lithium, sodium, potassium. So they were quite different in many aspects. So it is also considered as a demerit. So let's start with now let's bring modern periodic table. Modern periodic table was discovered by Henry mostly in 1913. It is this periodic table can be defined as the classification of elements based on the modern periodic law or atomic number is known as modern periodic table. The modern periodic table as the classification of elements based on the modern periodic law, which can be stated as the physical and the chemical properties of elements are the periodic functions of the atomic number. There are many advantages of modern periodic table which is used in present. Some of them are the wrong position of many elements are arranged in proper order, such as potassium, cobalt, nickel, etc. The isotopes of the same element have same atomic number, so they are kept in the same position in the periodic table. This periodic table separates the metals from non-metals, which were not done in Mendeleev's periodic table. There are some characteristics of modern periodic table, such as they are based on increasing atomic numbers. There are seven periods and 18 groups in modern periodic table. The inner gases like helium, neon, argon, etc. are kept in zero group at extreme right side in the table. So let's now in modern periodic table it is separated as groups and periods. So let's talk about periods. The horizontal rows of the periodic table where elements are where elements with gradual change and its characteristics with its atomic numbers are placed is known as periods. There are 7 periods in a modern periodic table. There are many characteristics of periods, such as valence electrons. All the elements of the period have different valence electrons in their valences. The number of valence electrons increases from 1 to 8 on moving from left to right. And the valency is also different in modern periodic table. The elements in the same period have different valencies. Across a period from left to right, the valency first increases from 1 to 4, then decreases to 0. Atomic size. Across a period from left to right, the atomic size decreases as the atomic number increases. This is because more electrons are added to the same cell, and the nuclear charge also increases with the atomic number. Metallic character. The metallic character decreases as the atomic number increases while moving from left to right in a period. Reactivity of nonmetals in a period. The reactivity decreases as we move top to bottom in an atom in a periodic table. For example, fluorine is more reactive than chlorine because the atomic size of fluorine is less than fluorine, which makes the fluorine have more force of attraction between the nucleus and valence electrons between its valence shell. So fluorine can gain one more electrons easily than chlorine. So fluorine is more reactive than chlorine. There are many uses of periodic table. It gives the finite distance characteristics of many elements. It gives us the prediction of new elements, and it gives the correct position of those elements as well. Now let's talk about electric configuration. Electronic configuration and its symbolic notation. The systematic representation for the distribution of electrons in different energy levels on an atom or orbitals of an atom is called electronic configuration level. There are electronic configuration. There are different elements and different configuration, electronic configuration, as well as their change in valency and atomic number, like shown in the chart. For example, the electronic configuration of hydrogen is 1s2, helium is 1s. The electronic configuration of hydrogen is 1s1 and helium is 1s2. Of sodium is 1s2, 2s2, 2p6, 3s1, as well as of calcium, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. In electronic configuration, the orbitals are filled in many ways, which is given as 1s, 2s, 2p, 3s, 3d, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7d, 5, 7s, 5f, 6d, 7p. In electronic configuration, there is a principle of which is also known as Anupam principle, which is a German word. It states that the electrons occupy the orbitals of minimum energy first, and then occupy the orbitals of maximum energy. So valency and atomic size determine the reactivity of elements. The elements of lower valency are more reactive than those who have more valency. For example, the metals with a big atomic size and non-metals with a small atomic size are more active than others. Thank you. Let me.
I'm Sujan standing in front of you to present the presentation on groups. So groups are the elements are the similar characteristics in particle columns is known as groups. So there are 9 groups. There are 9 groups numbered as Roman number 1, I2, VIIA, I2, VII, and except 0 and 7, except 0 and 7, except 0 and 8 all. Except 0 and 7 subgroups from 1 to 7 have subgroups. Subgroup A and subgroup B. Subgroup A and subgroup B. They are numbered as IA to VI like this. So group 0 has no subcell, but group 8 has 3 particle columns. So altogether there are 18. So altogether there are 18 columns, 18 groups in the modern periodic table. And position of different types of elements in modern periodic table. Position of metals, non-metals, and metalloids on the basis of characteristics like conduction of electricity. Elements are classified into metals, non-metals, and metalloids. So non-metals occupying right hand side, in metals occupying in right hand side. Group IA, the elements that belongs to group I are lithium, lithium, sodium, potassium, chlorine, etc. All groups, these groups has one valence here in the valence electron. They form monovalent captions like Li positive, Na positive. They are also called alkali metals because the hydroxides are strongly basic, so they are soft and very reactive. Group 2, the elements belonging to this group are beryllium, magnesium, calcium, etc. So these elements have two valence in their valence electrons. So they form bivalent captions. Example, B equals double positive. They are also called alkaline earth metals because they form basic hydroxide, which are less soluble in water. Group 6. The elements of this group are oxygen, sulfur, potassium, polonium, etc. The groups are termed as chalcogens because they are combined. They are formed by combining copper in nature. Group 17 or VIIA. The elements of this group are fluorine, chlorine, bromine, etc. They have 7 electrons in their valence cells. They are also called halogens. These are also called halogens because they form salt with group first, group A, group IA. Elements, for example, NaCl, etc. Now, group 18 or 0. The elements belonging to this group are neon, argon, etc. Except helium, all elements have 8 electrons in the valence cells. These elements are placed on extreme right and periodic table. They are also called noble or inert gases. Because they do not take part in chemical reaction. Transition elements, the elements of group IB2, VIIB are called transition elements. It can be said D block elements are transition elements. Hydrogen has 1 valence electrons in the valence cells. It has an equal chance of giving the valence electrons to other take part in electron from one to others. Lanthanides and actinides. Lanthanides and actinides are 2 series of inert transition elements, each having 14 elements. Characteristics of groups of valence electrons. So the atoms of the elements in the group have same electronic configuration in their outermost shell. Valency. In a group, almost all the elements have same valency. In a group, almost all have same valency. The elements of group 0 has no valency. Atomic size, this distance between nucleus and valence shell of an isolated gases is called atomic size. Chemical reactivity. The chemical reactivity of group increases on moving down. For example, sodium is more reactive than lithium. On the other hand, the reactivity of non-metals decreases when moving down in a group. Reactivity of metals. The elements of group IA, IIA, and IIIA are metals. The reactivity of metals increases on moving from top to bottom in a group. So, thank you.
Good afternoon to all. Now I'm going to explain about soft shell. The region around the nucleus where the probability of finding electrons is maximum is called soft shell. This known as orbital also. The atom having 2 electrons in a valence shell is called octet. Example is helium. The atom which contain 8 electrons in valence shell is called octet. An example is neon, argon. The electronic configuration based on 2n square cannot be explained. The electronic configuration of all elements. All the subshells are represented by the letter S, P, D, and F. The maximum number of the electrons in each subshell is given in the board. And main shell and subshell. The S subshell has got maximum 2 electrons and the P subshell has got maximum 6 electrons. The D subshell has got 10 electrons and the F subshell has got maximum 14 electrons. blocks of elements in the modern periodic table. The physical and chemical properties of the element depend on the arrangement of the electrons in the subshell. The elements in the periodic table are divided into 4 blocks. They are S blocks, D blocks, P blocks, and S blocks. The S block include the elements of group I alkali metals and 2 alkali alkali earth metals. They are present at the left side of the periodic table and they are 12 in number. And some examples of S block elements is lithium, sodium, and potassium. P block element include metals, non-metals, and inserts, which are present in the group 3A, 4A, 5A, 6A, 7A, and group 0. It is present at the right side of the modern periodic table. They are 31 in number. And the element of group 0 have computed field. NS2 and NS6 and P6 are known as noble gases. Some example of these are C and O, C and OF and AR, etc. D block element. The D block include elements of subgroups 3B, 4B, 5B, 6B, 7B, and 1B and 2B. The D block elements are also known as transitional element because they lie in the middle of the periodic table between S block and D block, P block. All of them are metals. And the example of D block element are silver, copper, etc. F block element. The element of lanthanide and antimonide series are called F block element. They are also known as intertransitional element because while moving from the transition element of group 3B and 4B, we have to transit through these elements. They are 28 in number. And the differences between S block and P block element. The S block element have S subshell as the last orbital and P block element have P subshell as the last orbital. They can have only 1 or 2 electrons in the last orbital. They can have 1 or 6 electrons in the last orbital. The chemical reactivity of the element increases while going downward in a group, and the chemical reactivity of the element decreases while going downward in a group. The melting point and boiling point decrease while going downward in a group, and the melting point and boiling point increase while going downward in a group. And thank you.
Today's topic was classification of elements, but I think they might have forgotten to say Mendel's periodic law and modern periodic law, right? What does Mendel's periodic law state? Physical and chemical properties of the elements and the periodic functions of their atomic weight. And modern periodic law, physical and chemical properties of the elements and the periodic functions of their atomic weight. Sorry, number. So, teachers have already taught 3: Samit, Sujan, and Rabi. Now, is there anyone who want to come and say from the beginning? Let's see. Sometimes that also can be given, right? Who wants to say from the beginning? Is there anybody ready? Shall I call or you want to come your own will? Because you have to be updated on this topic. There are very few days left for your examination. And what is the order of those orbitals? At first 1s, then 2s, then 2p, 3s, 3p, and 4s. Afterwards, 3d. What is there? 3d. So like, if sodium, what is the electronic configuration of sodium? 1s2,
2s2,
2s2,
2p6,
3s6,
3s1.
3s1. First of all, 1s is filled, then 2s, then
2p.
2p, then 3s. So what is the electron holding capacity of s? 2, p 6, d 10, and f 14. We have to remember. And in this chapter mainly you have to discuss about the differences between Mendeleev's periodic table, modern periodic table, drawbacks or demerits of Mendeleev's periodic table, advantages of modern periodic table. And did we discuss about alkali metals, alkaline earth metals, halogens or not? So group 1a elements are called alkali metals. Group 2a elements are called alkaline earth metals. Group 7a, VIIa elements are called halogens. And group 0 elements are called inert gases or noble gases. The group of 15 elements from lanthanum to lutetium. Lanthanum to lutetium. From atomic number 58 to 71, they are called lanthanides. And the elements from actinium to lawrencium, atomic number 89 to 103. What are they called? Actinides. Isn't it? Beginning lanthanum, lanthanides. Beginning actinium, actinides. So what are they? F block elements. In their valence shell there is F orbital. There are 4 orbitals: S, P, D, F. Who gave the idea of this SPDF orbital? Do you know? There is one principle in this topic. Aufbau principle. Who gave that principle? Wolfgang Pauli, one German scientist. Wolfgang Pauli gave the idea about orbitals, right? So he said, first the orbital with lower energy level will be filled, then only upper one. When you talk about K cell, it has got 1 orbital, L cell 2, M cell 3, N cell 4, then O cell 4, like this. So K cell only 1 means there is S. L cell there are 2 means S and P. M cell there are 3 means S, P, D. And M cell there are 4 means S, P, D, F. O cell S, P, D, F. P cell S, P, D, F. In that way we have to study. And elements from 4A, 5A, 6A, 7A and 0. These are non-metals. What are they? Non-metals. 1A, 2A, 3A, 1B, 2B, 3B, 4B, 5B, 6B, 7B, 8. They are metals. And there are some metals, some elements which show the properties of both metals and non-metals. We call them metalloids. So metalloids are found in group 4, 5, 6. Some elements like silicon, arsenic, antimony, bismuth, mainly 4 are there. What are they? Silicon, bismuth, arsenic, antimony. They are metalloids. They possess the properties of both metals and non-metals. Okay. So the mind mapping is very interesting one. See here. Just what is written here. Check this one, boys. So mind mapping, classification of elements is given, and Mendeleev's periodic table, characteristics, merits, demerits, modern periodic table, characteristics, then advantages, again groups, periods, characteristics of groups, characteristics of periods, and differences between group and period. So vertical columns are called groups. Horizontal rows are called periods. Vertical column, horizontal row. So in vertical column, when we go from top to bottom, in case of metals, reactivity increases. In case of non-metals, reactivity decreases. But in period, at first, chemical reactivity decreases, later chemical reactivity increases. Increasing, decreasing. So electronic configuration is given here. Main cell K, L, M, N, O, P, and here is given subcells S, SP, SPD, SPDF, SPDF, SPD, S, and P. Then 119 elements or 118. How many are non-kill love? 118. These 118 elements are divided into 4 blocks. What are those 4 blocks? S block, P block, D block, F block. How to know which block is it? Very simple. Group 1A and 2A, they belong to S block. 1A, 2A, S block. 3A, 4A, 5A, 6A, 7A, 0. They are P block. Can you see S block? 1A and 2A. P block? 3A, 4A, 5A, 6A, 7A, 0. Now 1B to 7B, group 1B to 7B and A, they are D block. They are transitional elements. And I said lanthanides and actinides, they are F block elements. They are given, and electronic configuration is mentioned here very clearly. So let's give a big round of applause for today's teacher. Actually, we are conducting this class for the increment of confidence level of students, right? So next topic is chemical reaction. So who are interested to do chemical reaction? Please come front. Who are interested? Okay, Vidyasadan, come front. Come from next. You can form your group actually. Next one, come here. If you don't come, then okay. Biru, come front. Next. Who is next? There was before. Sony, 3. Next. Asa? Okay, come. So they are the presenter for next topic. What is that? Chemical reaction. So come from Asa. You divide the whole chapter into 4 equal parts and take the charge of one part. So Sony, can she come tomorrow and do her? So if she is absent today, don't keep her. You can keep Ruju. Ruju, come front. Come here, Ruju. Come. Because the person who is not well, difficult, then it will be difficult, isn't it? So tomorrow's teachers are, who are they? Ruju, Asa, Vidyasadan, and Biru. Please practice and come tomorrow. Okay, thank you very much.